Hello and welcome back. We are on chapter 14, intelligence. So let's go ahead and get started. In this chapter, we're going to cover the question, what is intelligence? And I'm going to give you a spoiler alert. We're not really sure. The second thing I want to make sure to address is intelligence beyond the IQ test, the kinds of intelligence that's not necessarily measured on an intelligence test. And then a little bit about the roots of intelligence, why there might be differences between people, things like that. All right, well, let's jump in. In this first topic, I wanted to kind of mention that, intelligence and talent can sometimes be separable. There are cases of people who have very low IQ scores and then have like amazing talent. So I wanted to take a second and talk about people, what we call savants. Savants are people who have developmental or intellectual disability for some reason. It could be, something that they were born with. It could be that they had an injury, but they have extraordinary talents. Not just, like, oh, wow, that's good. It's like extraordinary talents, extraordinary knowledge of a certain subject, extraordinary abilities in a specific area. And usually these talents and abilities are going to surround things like music and art. It could be calculation or math. And like I said, it could be congenital. It could be something that happened during, fetal development, or it could be something that happened later in life. Some signs and symptoms of a person that might indicate that they are savant is that they have an IQ, an intelligence quotient, that's somewhere around 70, definitely below the average range. So they have what would be characterized as probably two standard deviations away from the average below intelligence, but then they have this genius level knowledge in their savant abilities. And they can appear and disappear quite suddenly. Sometimes people will have savant abilities show up and be there briefly and then they'll go away. But the savants that are probably the most famous are ones who are lifelong savants, where from the time they were really little, they displayed these, amazing abilities in whatever field or area that they are sort of a savant. They tend to, on average, have extraordinary memory as well. And so that's an additional part that kind of runs counter to some of the things that we say about intelligence. It could be caused by head trauma. There's actually a type of treatment for depression that has been tested to see if it can induce a savant condition temporarily, and it can. It's a magnetic treatment, so you can get like brief savant skills. It's a lot of times people just call it autistic savant when they refer to a person who has savant syndrome, and it's because there's such a close association between savant capabilities and then autism. But this little flyer that I found said about 10% of people on the autism spectrum will display savant abilities. It's hard to know exactly how many actually have these abilities. It might be much less than that. We're not sure. But it's not like there's anything wrong. So it's not diagnosed per se, but it's like recognized. We notice that a person has these abilities. And so the fact that you can have much below average intelligence, not just below average, but like well below average intelligence, and then these like genius capabilities with regard to math and music and art and things like that, really show us that intelligence and then, talent are probably different things. So that's my beginning of starting to address the question, what is intelligence? And I'm not going to quite define it maybe the way that you would expect if I was going to tell you what something is. I'm going to tell you sort of how we categorize it. So I'm skirting the question. So is it one intelligence in general? Well, Spearman said yes. Spearman said we have general intelligence. He called it G, very creative. And then he says, yeah, we can have some specific intelligences. He called those S. But those were harder to measure and might look more like talents. And that they might really rely on G, that in the absence of G, you wouldn't have much of S. So he really believed that fundamentally underlying intelligent behavior was this one fundamental thing. Sternberg, which we're not going to have time to really talk about, but I wanted to throw in for your knowledge. Sternberg introduced the idea that there might be three components to intelligence, and that, classically, G and other models of memory have looked at only the analytical and intelligence, the kind of intelligence that you need for logic and math and language comprehension and stuff like that. And that the traditional models have forgotten about things like creativity and practical intelligence, street smart, stuff like that. Knowing how the world works would be practical intelligence. So Sternberg says, all three of these are important. And in certain fields, you need all three. And in other fields, maybe you only need two of them, or things like that. And so he's making an argument for a new model of approaching intelligence. And then there's Gardner, who says, well, when I was a college student taking this class, so back in the olden days, he only had seven different kinds of intelligence. He's now up to 9. So he keeps adding on. But Gardner is suggesting that, yeah, there's analytical components. Then there's also, some interpersonal and intrapersonal components. And then there's some things that a lot of people would call talent, but he says are intelligences. We'll get to Gardner's theory a little bit later. So we'll get into that more, and we'll definitely revisit Spearman's theory. But I just wanted to, sort of answer what is intelligence on the side of, well, it might be one thing. It might be 3 things. It might be 9 things. There's actually a researcher called Guilford who thinks there are 120 specific different kinds of intelligence. So is it one, or are there different types? I don't know. Okay, now this one I do know. How is intelligence measured? Okay, now this I know. Originally, the concept of intelligence testing was sort of put together into this formula that got labeled the intelligence quotient, or IQ. So to compute that, you would take the person's mental age, and that is the score that they got on the test. And you divide it by their chronological age. And then you multiply it by 100, and that's going to give you an IQ score that's going to range from basically 40 to basically 160. There are some details about that, but basically those are reasonable. So the mental age part of it is based on the concept when intelligence tests were first developed, that we could develop age norms. And we could figure out how the average 4-year-old would answer these questions, or the average 8-year-old, and so on. The problem with mental age when you're talking about an adult is that once we get out of high school, we don't have a consistent set of knowledge that we expect a person to be acquiring, right? Anything else that you're acquiring is very idiosyncratic in adulthood. Whereas in childhood, there's like very predictable developmental phases that you go through. And so if you're going to be talking about adults, it's going to be really difficult to talk about their mental age. Even with children, though, today we don't really go to the trouble of calculating mental age and dividing it by chronological age. Today, we typically compare an individual's score to a distribution like this. And this is what we call a normal distribution, which is going to provide to us the norms for what we would expect. So we take your raw score on the IQ test and we compare it to other people, the norms raw score, and that allows us to convert your score into a position on this normal distribution, and that's how we report your score to you. So you don't have to get every question right. You don't have to be perfect on an IQ test. You just score like other people, and then we figure out what that number is. I was reading up a little bit on people's concept of what these norms mean in intelligence testing, and the average everyday layperson doesn't seem to really understand what norms do. Like how I said earlier that a score of 70 is 2 standard deviations away from the mean, like what that means. So when you administer the test to the first group who's going to ever take this test, and you're trying to figure out, okay, what's a normal score? That word normal is based on the term norm. So what's the average score for this sample? You administer the test to a bunch of people, and you try and find, a group of people who you think are going to represent this characteristic. So in the case of intelligence, that would be anybody. That would be all, all different kinds of people you would like to have take the test. And you figure out what the average score is. That score was labeled 100 by the initial people who ever made up tests. So they said average is going to be 100. And then you compute statistics on these norms to determine what score delineates this lower boundary on what we call one standard deviation, and then what score constitutes the upper boundary on one standard deviation. So for IQ scores, they have arbitrarily set the average to be 100. One standard deviation turns out to be 15 points below average and 15 points above average. That range, one standard deviation, statistically, what that term means is that one standard deviation away from the mean on any normal distribution, not just IQ score, one standard deviation away from the mean will always encompass 68% of the respondents on whatever you're measuring. So that's just how normal distributions work. And so we have 68% of the population falling between 85 and 115 on an IQ test. By setting the average score at 100, this is how we ended up with the 85 as the bottom and 115 as the top of the normal range. So if your IQ score is within that range, you're considered normal. Now, unfortunately, in the way that humans use language, when we hear normal, humans start to say, I'm normal, therefore that makes you abnormal. And abnormal, bad, normal, good. And that's not what these terms mean. They refer to the original word that just means norm. I'm clustering around the same average that most of the participants in the norming sample clustered around. Now you'll notice there's this blue area here that's between 70 and 85, and then between 115 and 130. That's one more standard deviation away from the mean. So if we go one more standard deviation, so we go 2 below to 2 above, we end up with 98% of the population falling within that range. So the vast majority of people fall within 2 standard deviations away from the mean. 3 standard deviations away from the mean will take us very low and very high IQ scores. So, and those are very unusual. 4 standard deviations, it's like 0.01 or something, like a tiny number of people are going to be in those areas. So this is characteristic of any normal distribution, and IQ scores are normally distributed. When people are tested, this is how it pans out. When we have norming samples, this is how the curve tends to fall. So that's step 1, is that we no longer compute that intelligence quotient directly. Now instead, we take the score that a person earns and we compare it to the norms and see how they're falling relative to other people who have taken the same test. All right. I think that's enough of an intro. We're going to look directly at how IQ is tested using an example called the WACE in our next video.